Hello everyone, welcome to Legacy IS. We'll be continuing with class 8 NCERTs of science. Today we'll be doing chapter 3. Okay, let's get started. Yeah, so this is chapter 3, which is health, the ultimate treasure. Now, this is mainly about what are the different things in health. Like in the earlier chapter, we had covered about microbes, correct? And the good things that microbes do. In this chapter, we learn about what is good health and what are the diseases that are caused by these microbes or otherwise, which are harmful or makes you unhealthy. So all those we'll try to learn. Now, so first is this exercise, okay, that how your body responds to this, that, all that is there. Then we get to the main part. Okay, so yeah, so it gets started with this. So basically, first thing is health is not just about not falling sick. Even if you're not sick, you may be not very healthy. Correct. So it goes beyond having disease or being sick. Then this is a good definition that you can use in mains also. As per WHO, health is a defined as state of complete physical, mental, and social well-being, and not merely the absence of disease. Correct. State of complete physical, mental, and social well being, not merely the absence of disease. Good definition. Then, a healthy person will be able to perform things more efficiently. This you understand. Then, our scientific heritage. So, in India, from Ayurveda, we had things like Dincharya. Dincharya is daily routine. Ritucharya, which is our seasonal routine. Like in Savan, we should eat these kinds of things, we should not eat this, that, all that comes from Ritucharya. Then Prakriti, so body constitution. So they have defined three types of bodies, okay, and based on that, you should be consuming food. Like some people are such that they can eat a lot and they won't be gaining any weight. In fact, if they don't eat enough, they tend to go even thinner and thinner. And there are some people who don't eat anything and then also they become fat. Correct. So all those are different body constitutions. This is called Prakriti. So we have defined this in ancient times also at very decent level. Then how can we stay healthy? So of course, what you can do, you can maintain a healthy lifestyle, balanced food, processed food you should avoid, physically active, limit screen time, get enough sleep, practice yoga, say no to harmful substances. Okay, all this. Then it also talks about that environment is also a very important component of how healthy or healthy life you can spend. Correct. So there is a comparison between this A and B. These are two playgrounds. Now this you can see is very clean. This is dirty. Correct. Now all this are forms of environmental pollution. One thing it defines is what is air quality. So air quality index actually helps us to understand how clean is the air in which we are breathing. Then now, it also talks about that it is not just about our physical health, our feelings, relationship, all these also matters. Correct. So that is why even if we are in a healthy or clean environment, we can still feel lonely or upset. That's why mental health is also very important. Then, how do we know that we are unwell? Of course, there is something known as symptom. Correct. Now, what is a symptom? A symptom is what we feel like pain, while a sign is something that can be seen or measured, like high body temperature we have. Correct. So, basically, if there is something you can feel, then it will become a symptom. Correct. And if there is something that can be measured and can get you some immediate conclusions, then this is called science. Correct. For example, your body temperature has risen. For example, if I give you an example of dengue, correct, dengue you might have heard. So in that people start feeling very cold. कपकपाहट होने लगती है. Correct. What is that? They feel like they are shivering. Correct. Now that is a symptom. But if you see the sign, if they take the temperature, the temperatures will be higher. That means what? That means they have high fever. Along with that, why they are feeling cold? That is a symptom that they may have got the dengue virus. Then, then diseases. What are the causes and types? So diseases is anything that goes against the proper functioning of your systems. It may be because of you ate something, some bacteria, some virus, or because you are having some very unhealthy diet. It may be something that comes from your genes, that is from your parents, hereditary. So all those are different ways or kinds of diseases. So here they have defined very basic ones only. So the disease, they have defined two kinds of diseases: non-communicable and communicable. Correct? Non-communicable means something that can spread from one person to another, like all these diseases that you have. Correct? Sorry, I said wrong. Non-communicable is something that do not spread from one person to another. That is why it is called non-communicable. So examples of this is cancer, diabetes, asthma, all this. Now, communicable disease is something that is caused by pathogens and thus can be spread from one person to another. Example of this is dengue, chickenpox, COVID-19, typhoid, flu. All these are caused by different kinds of pathogens. We'll read about now. First, let's see what is a pathogen now. So, disease causing organisms are called pathogens. As simple as that. Other diseases may also result from poor nutrition, unhealthy lifestyle. Basically, there are many ways you can get a disease. Then, then in recent years, non-communicable diseases like diabetes, heart disease, cancer have become more common in India. Correct. Then eating more processed food, getting less exercise, and living longer lives. All these are actually living longer lives. You are understanding? Because of modern medicine, we are living far too long. Correct. So we are living like 80, 90 years. And then cases of all these non-communicable diseases also increases because of old age. This you anyway understand. Processed food, less exercise. Then, then how are communicable disease caused and spread? So all communicable diseases are caused by pathogens. Fine. Then, but how do these pathogens spread from one person to another? Now, some common ways you do understand. For example, if I have common cold and I am sneezing constantly, then you may also get it. How? From the water droplets, from the cough that is coming out of me. Correct. So basically, when an infected person coughs or sneezes, or through direct contact like shaking hands, indirectly by sharing personal items, okay, because of all these reasons, what you can, there can be spread of a disease. Then some of the communicable diseases spread through contaminated drinking water or food. Then some pathogens are also spread by insects like mosquitoes, house flies. These insects are called vectors. Correct? So there are many ways. One is that direct contact, one is because of some sneeze, cough, and all that. The other can be by pathogens or by something we know as vector. Vector is something that is carrying the disease. For example, malaria, we say it is caused by mosquitoes, but actually, mosquito is just a vector. Correct? The pathogen there is Plasmodium. So that is a different thing. The mosquito carries it. So that is why it is not a vector. It is not a pathogen. The mosquito is a vector. Then, then these are some diseases and how they are. The causal agent and site of infection is given. Symptom preventive measure, not very important. Common cold, influenza, virus, respiratory. What it affects? Respiratory tract. Then chicken pox, correct, virus again, respiratory tract and skin. Measles is again virus, same. Then tuberculosis is bacteria, it affects the lungs. Correct. TB, you might have seen people coughing continuously, and that cough not getting treated in 1 2 months, 3 months. If it extends beyond that, then there used to be an ad on TV that if your cough extends beyond, if you're constantly coughing beyond 1 month or 3 months, then you may be having TB, so you should get checked up. India has one of the highest TB burdens in the world. Then you have hepatitis A, which is again caused by virus. It affects the liver. Then, so hepatitis A actually you get from, so this actually comes from, like, if the water, if the food and all that you're not consuming. So this is called fecal oral. So from that route you get hepatitis A. Then there is cholera caused by bacteria, again affects the intestine. Typhoid bacteria, intestine. Then roundworms, worms, intestine. So one thing you should know that this is fine. Of course, from somewhere you can get worms. Now your body, we have talked about this in the earlier chapter also, microorganisms. So your body, your gut already has some bacteria and worms naturally. Okay, naturally also it has it. Then diseases transmitted by insects. Let's see. So there is malaria, there is dengue fever, correct? So why it is written by insects? So here the vector or the carrier is a insect. For example, malaria actually makes use of mosquitoes. Malaria makes use of mosquitoes to go from one place to another, the pathogen in this. Similarly, dengue also uses mosquito, correct? So these are diseases that are spread by or transmitted by insects. Then, yeah, this we have talked about, that some infectious diseases are caused by worms that live inside our bodies. As I told you, some bacteria, worms, all this live inside our body, especially in our digestive system. They feed on nutrients and live as parasites. What are parasites? Parasites are something that lives on the host body completely. Correct. So parasites lives on host body. It takes every nutrient, everything from the host body itself. Then, how are non-communicable diseases caused? Now, so we are done with communicable diseases. You saw how it is spread. Some examples of this, very basic. Now we come to non-communicable disease. See, it is not saying spread. Why? Because non-communicable disease are not spread. They do not spread from one person to another. How they are caused is the question. Correct. Now, one of the most, see, famous ones, cancer, diabetes, asthma are linked to lifestyle, diet, and or environment. So these are the lifestyle, diet, and environment. These are the major causes. One more you can add that is not given here. That is genetic or hereditary. These are the major reasons of non-communicable diseases. Then, so which are caused by lack of specific nutrients. These are called deficiency diseases. This we have done in 6th or 7th class. Correct. Different kinds of deficiency diseases. If you remember, vitamin A deficiency, night blindness. Correct. All those. So that now. Diseases such as cancer, diabetes, and asthma may often persist for a long time, more than 3 months, and are referred to as chronic diseases. Chronic diseases is which affects you for a very long time. Okay, even after you become sort of fine with it, then also it keeps affecting you. That is chronic disease. Then it talks about diabetes and tells that India has one of the highest burden of diabetes in the world. What are the reasons? You already know now. We have an extremely carb rich diet. That is the major issue. Then next thing. So basically these are certain non-communicable diseases. Then it talks about one scientist, that is Kamal Randive. Okay, he did many researches relating to cancer to find out what can be the better treatment, how we can prevent cancer, all that has done. Then it talks about how to prevent and control diseases. Okay, so it talks about one of the initiative that is in Odisha. See, many diseases were being caused from one person to another, for example, by cough, sneeze, okay, all these things. Then by shaking hands, their hand may have something. So all this can be stopped just by simple sanitation campaigns. This is what was being done in Odisha. So in Bhadrak district, Odisha, a community sanitation campaign helped more people build and use toilets. Correct? Then this reduced open defecation significantly and improved child health with fewer cases of diarrhea and infections. Correct? So basically just basic things like sanitation campaigns and promoting people to build and use toilets so that they get clean environment. So open defecation was reduced. Now open defecation is a major challenge in inside, like if you go beyond metro cities, correct, so then you start seeing, especially in villages, open defecation issues, correct. So with reduced open defecation, it had a lot of positive health outcomes. Then ability of the body to fight diseases. What is this? The natural ability of a body to fight diseases is called immunity. Okay, we learn about types of immunity also when we do biotech. So immunity is something that our body has to fight of the diseases. You might have heard of WBCs, correct? So all these are immunities. Now, yes, then so vaccines that help prevent serious infection caused by viruses and bacteria. Now understand what is vaccines, but before that you must understand acquired immunity. Now, what is acquired immunity? So, this is the protection developed after exposure to a pathogen or a vaccine. Vaccine can be made in different ways that we'll see. So, first you understand one thing is called innate immunity, correct? That you have from your birth. Other is called acquired immunity. Acquired immunity is something that you get later. Okay, so acquired immunity. So once you get a particular disease, okay, once you get a particular disease, now your body tends to remember, that particular pathogen, correct, and the next time the same pathogen comes to your body is able to respond much better. Okay, all those detailed concepts of what kind of a response is acting, that we'll see in higher classes, but you understand this, that once you have gotten the disease, then the next time the same pathogen comes, your body is more ready to deal with it, correct. That thing that I told you just now is called acquired immunity, correct. This was not from your birth, this was once you got the disease, or once you developed exposure to that particular pathogen, you became more able to deal with it. Now see, so how vaccines help in doing the same thing, understand that. For example, if I, if this is I, this is, let's say, a person X. Now X got disease A, and somehow his immunity fought it, and now he is free from disease A. But now X has immunity with respect to A, correct. Immunity with respect to A he has. Now the next time A tries to enter X, it will be very difficult because X already recognizes everything, correct, how to deal with this that, so it will be able to fight it off very well. Why? Because of acquired immunity. But for that, X had to get that disease, which itself is not very safe. It must harm his body in some way. Okay, sometimes maybe survival also becomes difficult. So, similar thing is generated using vaccines. So, vaccines do what? For example, they will take the dead version of that pathogen or a weakened version of that pathogen, very weak version, which cannot cause disease in you really. So, what will happen? So, now X will be, this is disease A. So the pathogen that caused the disease A, it will be entered. For example, the weakened or the dead pathogen will be entered. Now, what X's body will do? It will first fight it off, which is very easy because it is already half dead sort of, and it will create memory of this particular disease or pathogen. Then the next time A comes, your body is already ready. Correct? Same process, but here you had to get the disease to get the acquired immunity. Now, using vaccine, you are getting the acquired immunity, but you are never getting the disease. Understood? This is the whole concept of vaccines. Now, let's see. So, vaccines can be made in different ways, from weakened or dead pathogens, or from inactive or harmless parts of the pathogen. All these can be used to make vaccines. Correct? Different kinds of vaccines we'll see later. And then some newer vaccines, in fact, don't even use the pathogen. So they just take some part of pathogen. For example, the outside protein, antigens, we learn about them. That only they take, which generates immune response, correct? And they will enter that only in your body, so that you are very safe, and you can get immunity, acquired immunity against it. Then see, vaccine instruct our own body cell to make harmless part of the germ which our immune system learns to fight. Now, this is another kind of vaccine called. So basically, we won't go into details of the name. So basically, what it does, instead of sending the pathogen, weakened pathogen, part of pathogen, what they will send some genetic code. Now, through any kind of thing. So genetic code is sent to your body. Now, using this genetic code, your body is first able to create parts of pathogen. The parts of pathogen that generates immune response, that it will generate first, and then the body itself, to fight this off, will generate immunity or acquired immunity using something we know as antibodies. Okay, so basically acquired immunity will be generated. Then it talks about one of the important diseases, that is called tetanus. Okay, so here what they use inactivated bacterial toxin. Okay, we learn this when we study about types of vaccines. Then then it talks about how the first vaccine was discovered by Edward Jenner. Now, see, smallpox was a very deadly disease in the 1600s, 1700s. Now, what this guy Edward Jenner saw, that there is another very mild disease, a very milder disease, that is called cowpox, which is seen in cows, could also infect humans, but not very harmful. Correct? Very mild disease. Now, one weird thing he saw was people who had or who were in contact with cowpox. Maybe they were working in dairy, or because of any reason, if they got in contact of cowpox, it may have caused some mild disease, but after that, they were not getting this smallpox. So they were safe from this deadly disease of smallpox because of having cowpox. So this triggered a bell in his head that this can be used to make something known as vaccine for the first time. So what he did, this led to the invention of first vaccine and helped protect people from smallpox. Okay, now in India we had a similar thing much before. So what we used to do, for example, same thing to fight off same smallpox. So somebody who got a smallpox, from their skin, we will take small fragments of it and we will try to introduce it in some other person's body. Now, of course, it can have repercussions, like sometimes if that person is not that strong in immunity, he can get the disease itself. But in that small amount, usually body is able to fight it. Immune system is able to fight it, and then they tend to get acquired immunity against it. Correct? So this is what we were doing then also, and these people who used to do these things were called TKDAs. In Hindi, we still call vaccine as Tika. Correct? Then, so this is what. think like a scientist. This is what he did. So basically, he took Edward Jenner, similar thing he did. So basically, he took out content in the pus of cowpox blisters. Okay, so what he did, small disease were there, correct? So from cow or from humans, from the cowpox blisters, which is a very mild disease, they took out some content, correct? And then this content was introduced in people. Because of this, what people developed acquired immunity, or acquired immunity against our smallpox also. That means these people became safe from smallpox. So this is what was that. Then eventually mass vaccination was done like this, and it helped to eradicate smallpox worldwide. Now we don't have smallpox. Then see, so vaccines are one of the most effective ways to protect people of all ages, from infants to elderly, against many serious diseases, all this. Then it is important to remember that, see, at this level they have written that vaccines are preventive, not curative. Correct. So the main aim, as you understood, of vaccine is to prevent diseases. How it will prevent diseases? Cause some mild infection, some mild form of infection in you, so that you develop immunity against it, and the time when the real pathogen comes, your body is able to fight it. Correct. This is the main aim that we were talking about. Correct. Now there are also passive vaccinations, but that we'll see in higher classes. Then getting vaccinated not only protects you but also protects the people around you. Why it is saying so? Because, for example, if we are talking about some communicable disease, correct? For example, COVID-19. Now, if everybody got vaccination, then they won't be getting the COVID-19. Also, they won't become the carrier to carry COVID-19 to other people. And that is why vaccination protects you at a community level also. Understood? Then, then it talks about that India is one of the major vaccine producer in the world. Correct, one of the largest vaccine producer in the world. We have manufactured most of the vaccines of COVID-19 also, that was sent globally. Then, then see this scientist. This is Maharaj Kishan Bhan. Now, what he did, so basically he was a well-known Indian doctor and scientist, and he was the secretary of Department of Biotechnology, and then they started or developed rotavirus vaccine. What is rotavirus? So rotavirus is a very severe cause, very severe kind of diarrhea in children. Diarrhea, I think everybody knows, okay, like loose motions. So this is what was infecting a lot of children. So we developed rotavirus against it. Okay, rotavirus vaccine against it. This person was involved in it. Then, yeah, treatment of diseases. See, if immune system is able to fight, nothing like it. Correct? It's the best thing. But if the immune system fails, now what happens? You go to the doctor. Correct? So the doctor may give you some medicines that are called antibiotics. Okay? Antibiotics are given by the doctors which kill the bacteria that might have caused the disease. Correct? So basically, antibiotics is something that can be given. Now, antibiotics specifically work well or work against bacteria. Correct? Not so much against other kinds of pathogens. Correct? That is given. Antibiotics work only against bacterial infection because they target parts of bacterial cells. that are different from human or other animals. They do not work against viruses or disease caused by protozoans. Then she understood what is antibiotic, that can kill the bacteria that is causing it. Then let's talk about the first antibiotic that was discovered. This is called penicillium or penicillin. Now, this is discovered by Alexander Fleming. Okay, he was a bacteriologist from London. Now, what he did, see this. So he was trying to understand some harmful bacteria, how they work and everything. So when then he noticed that these bacteria mold on a discarded petri dish stopped the bacteria from growing. So there was a petri dish that was discarded. Now it had developed mold. Now somehow he observed that because there is some mold present, this bacteria was not able to infect it. This surprised him, that how this mold was protecting itself from this bacteria. Correct. So basically, mold is a kind of, as we understood in the earlier chapter, mold is an example of multicellular fungus. So basically, so he realized that the mold is actually releasing a substance that killed the bacteria. Correct. Then, so this led to the discovery of penicillium, the first antibiotic used to treat bacterial infections. Correct. So what he started taking, he started making something known as antibiotic using this, and this was able to, of course, this is able to kill the bacteria because of release of some toxin. So from this he made the antibiotic which can kill the bacteria. Then it talks about a current affairs issue also. Okay, that's why I said that this chapter actually involves a lot of things. They have introduced a lot of concepts. Okay, then so it talks about something that we now know as antibiotic resistance. What is this? This is the phenomena where bacteria that were earlier killed by a given antibiotic are found to survive and multiply despite treatment with that antibiotic. Basically, some antibiotics used to work very well earlier, but over time, what has happened? Over a time, what has happened? That the antibiotics are not that effective on the bacteria anymore. Now, why is that? That we will understand. This phenomena, that the antibiotic which was very effective earlier is not very effective now, is called antibiotic resistance. Then, how antibiotic resistance spreads in the community, that we'll understand. See, so this is antibiotic, let's say. Now, there are two ways. One is development of resistance in bacteria in animals. So now, if you take antibiotics when they are not required, or you take incomplete doses of them, your body does not require it, correct, and or you are taking incomplete dose, so then what will happen? All the bacteria that should be killed won't be killed, all those issues, correct. So if that happens, then there are two routes. Where can this happen? This can happen with animals also and human also. Now see this animal route first. Yeah, so basically what happens, let's say this is cow and it has been administered some kind of antibiotic indiscriminately when it was not needed. Now what will happen? So basically one thing is, when it releases the feces, anything, then with that also this antibiotic will be spread in different parts of the crop field, correct. That is one issue. Then through the crop field, it can be absorbed by plants, and from plants, when we eat them, the all these people can also get the same antibiotic, or it increases the resistance of bacteria, correct. Then next way is directly taking animal produce. This also increases the risk. Then the other path, that is the human is taking antibiotics when it is not required or incomplete dose. Now what will happen? So may have serious illness, get care at a hospital, spread directly to other patients or indirectly to health workers. Then this is spread in hospital, correct. Patients go home and then spread in the community. So this is the way how antibiotic resistance spreads. Now understand this also, it will give you more clarity. Now how bacteria is actually becoming resistant to antibiotics. So basically what happens, see, few bacteria develop resistance to antibiotics. Why? Because there is so much antibiotic being supplied when it is not even needed. So some of the bacteria will survive it. Correct. Now, if some bacteria survive it, now what happens? When antibiotics kill bacteria causing illness, they also kill good bacteria that is protecting the body from infection. So good bacteria are also gone, and there are some bacteria that are becoming resistant to antibiotics. Now what will happen? Over time, who will survive? The resistant ones. Good bacteria are dying, so the antibiotic resistance bacteria will grow more and eventually it will start taking over. Correct. Then same bacteria will transfer antibiotic resistance to other bacteria, also causing more problems. So eventually, if you look at it, it is basically an example of natural selection. Ultimately, most of the bacteria will be antibiotic resistance, and then your antibiotic stops working. Correct. So this is how they work. Then, so to tackle the problem, what we must do? So we must always take antibiotics when prescribed by the doctor and in the correct doses and for the right duration. And unnecessary use should be avoided so that these antibiotics are protected for our future generations also. Also, we can use traditional medicine for small things. For example, if I'm getting cough and cold or anything, correct? So I should not be taking antibiotic, correct? There are traditional ways of dealing with these like Ayurveda, Siddha, Unani, correct? There are some herbs, oil that you can take and then you will get over it, correct? So that is why we should not be always taking in antibiotics. Correct. So they may not be effective for all diseases at all stages. So all these traditional medicines also, of course, not effective for all diseases at all stages. Sometimes people tend to claim it wrongly also. Correct. Like some people claim that it can directly cure cancer. Okay, even the last stage cancer, all that. So all that is actually wrong. Then therapies for non-communicable diseases focuses on managing symptoms and improving quality of life through medication, lifestyle changes, and rehabilitation. Correct? Because there is no pathogen that you can kill by antibiotic. All that. What you need is lifestyle changes and symptom management. Correct? So this is what is needed for non-communicable diseases. Then this is one graph that is given that is talking about the number of dengue cases that are there. Okay, so if you see here, number of dengue cases, it increases in July, August, and September. Can you tell why? Because after monsoon, what happens? Water is present here, there, everywhere in some places, and the growth of mosquitoes increases a lot. Correct. And that is why after monsoon we tend to see more issue of dengue. Okay, so these are the diseases that we had to study about. The next chapter we will do in the next class. That's it. Thank you.